Welcome back. This is the start of Unit 2, which is differentiation. Our first lesson is an intro to derivatives. First of all, what is a derivative? A derivative is the rate of change of a function. So, you know how you use the slope formula like this to determine the slope of a linear function? Derivatives are more meant so that you can find the rate of change for functions where it's hard to use that formula. So this would be actually a really good example. This is a really complex formula, x squared cosine 3x, and you can actually use the derivative to find the slope at any given point. We will get into that later. Do not worry about that. Don't get scared. The function looks scary. We'll learn rules for that later on as we go. So let's start by the definition of a derivative. This is the definition of a derivative. The derivative of a function is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now don't worry, you're going to rarely use this, but it's necessary for me to teach you this because sometimes they will require you to know it for exams. So I want you to know this in the back of your mind. Just kind of keep it in there, even though you rarely have to use it. And this is the formula for a derivative at a specific point. So here's an example of how to use the definition of a derivative to evaluate a derivative. So here we're given d dx is basically just saying we're taking the derivative of the inside here. So derivative of x squared plus 4. So how do we take the derivative of x squared plus 4? So let's go ahead and start by plugging it in. So we know that the formula says that f of x plus h minus f of x over h. Now f of x is x squared plus 4. So all we have to do for the x plus h thing is wherever you see an x, you just do x plus h instead. So that's the only change that you see there. Now we're going to factor that out, and we get this big monstrosity here. But don't worry, because some of the terms will cancel out. And it leaves you with this. 2x plus h, 2xh plus h squared over h. And of course, limit as h approaches 0 of all of that. So now we're going to go ahead and factor out an h at the top so we can cancel out the h from the top and the bottom, because notice how both terms on the top have an h in them. So we're able to factor that h out. Then we go ahead and cancel that out, and we're left with the limit as h approaches 0 of 2x plus h. Well, as we learned in our first unit of limits, we can take away the limit notation and plug that 0 right in. So we have 2x plus 0, and therefore we get that the derivative of x squared plus 4 is equal to 2x. Now, there's actually a simple way to do this. This is called the power rule. If you have any sort of x raised to an nth power, the derivative of it would just be that power multiplying the x raised now to the x to the n minus 1. So here's an example. If you have derivative of x to the 4th, you just take the 4, put it in the front, and then subtract 1 from the power. So you're left with 4x cubed as your derivative. That's an easier way to do it. Hopefully that helps, and that doesn't leave you to have to do the whole process that we did earlier all the time. There are way simpler ways. So yeah, just keep that in mind. Thank you.